I will do my presentation on the Ig Nobel talk by David Hu on the science of urination. So he started out talking about how there are many things mammals have in common. How he was fascinated with eyelashes because they're all about 2/3 the width of the eye, and they're aerodynamically correct so that they keep your eye from drying out. We moved on to talk about his main topic, which was urination, and his unfortunate grad students had to collect samples, and we joked around about that for a little bit, and he talked about how the Ig Nobel is designed for science humor, and how it's supposed to be funny so that the general public will first be interested and then possibly remember the just little bit of physics from the overall funny presentation. The main point was that mammals take about 20 seconds to relieve themselves. The physics behind this was relatively simple. You have the cross-sectional area and the volume of the bladder, and then you have the force of gravity. So the linear velocity of urine leaving the bladder is caused by gravity, and the linear velocity times the cross-sectional area gives the volumetric flow rate. So the interesting part about this was the volume of the bladder and the cross-sectional area were proportional so that while gravity works about the same for just small heights on the Earth, the volumetric flow rate was proportional in a way that the bladder would be empty in 20 seconds. Across the board, it takes about 20 seconds for mammals to relieve themselves. That is exceptionally fascinating, mainly because we go from cats to dogs to elephants. Mice were in there. So it's an interesting thing that wide range, that wide size, would all take 20 seconds to pee. Relations to this outside of the presentation, I am currently a chemical engineering student, so we work with a lot of flows of gases and liquids, and it's always very important that the volumetric flow rate of the stuff moving through the pipes, the cross-sectional area, linear velocity, is all correct so that the same mass, the same volume is going through. Correct reactions, and that's all flowing out. And definitely that it's all flowing out is an important part, because if you start to accumulate inside of a reactor, stuff will blow up. So it was fascinating to see just the proportionality. Yeah.